In this presentation, Dr. Jason Matlock, data scientist at Fluence, explores how cannabis cultivators can turn overwhelming data into actionable insights to boost yield and efficiency. This presentation was delivered live at MJBizCon 2024.
I've talked a lot about data before. People may have seen that, but if you're out in the world and you want to talk about making it accessible, not confusing, but accessible, where do I start with using data? How do I make it useful in my grow in a way that's not overwhelming? I'm not a data scientist. How in the world can I do this? This is the talk for you. Let's set the scene here really quick. So we know that the cannabis industry is commodifying. Profits are more difficult to make. It's not enough to just grow cannabis. In fact, it's not even enough to just grow cannabis well. You have to run an efficient business. That's primary. The question always is, how do I do that? How do I reduce costs? How do I avoid mistakes? And what cannabis business operators routinely get as an answer for that? Well, you need to use data. You need to make data-driven decisions. Okay, that's great. Where do I start with that? There's truth to that statement, right? Data is the basis for making informed decisions. You have to benchmark what you're doing. You have to monitor processes. If you don't have a metric, how do you know what the impact of your decision was? You can't. So it's critical that we have data, but it's very difficult to figure out how to use it. The key here is to recognize that collecting data is not the same as gaining insight. There's a lot of companies who are collecting data, and they're drowning in it. They have all sorts of records, but they're not learning anything from that material. And the reason for that is because there is a process for going from data collection into actually gaining insight. There's a lot of names for it. Collectively, we call that data science, right? Just like the scientific method. There is a method for moving through and collecting data intelligently. And we're going to talk about that today. That's barrier number one. Barrier number two is that popular culture really hasn't done data science any favors. We live in the world of AI, neural networks, native language models, very complex stuff, big data. And the perception is that's what data scientists have to do. That's what they are about. And as a grow, then I must have to use something that complicated. And I don't know how to do that. That's overwhelming. Those are tools used to solve big problems. And that's great. And it's really exciting. But that's it. They're just tools. That's not data science. Data science is the process of collecting data, collecting information, and learning something from it. So you need to recognize that we can achieve insight through very simple methods like box plots or line plots. It's not about the tool. It's about the question. And it's about the process. The final thing that I want to kind of get into here is that ultimately there is a philosophy, an approach to data science. So I want to talk about that. And I want to talk about the fact that the starting point for data science is formulating intelligent questions. And it's about creating things that are accessible. And data is accessible. So that's really the focus of this talk, is we're going to look at how data science flows and how to formulate the right kind of questions. So where do we start? Let's start with a pretty common tool. I think most of you are familiar with this structure. This is called a dashboard. There's a lot of companies selling dashboards to cannabis growers right now to visualize data. We're going to walk through this, and we're going to talk about where there's some good stuff, where there's some bad stuff, and how we might improve as an example of using data science. So this is specifically focusing on web analytics. So it's telling you where your traffic is coming from in terms of leads. It's telling you how people got onto your website. It's telling you where they live, and it's telling you how much traffic you had. So that's great. Is this useful? Maybe. It depends on the questions that are critical to my business. This could just be a colorful graph. or it could be some of the most insightful and powerful information that I have as a business owner. It depends on what questions you need answered. For example, this guy right here is telling us that we have more than 2/3 of our business coming out of 3 sources. So if I'm answering the question of where should I focus my budget for advertising, that's really powerful. I could probably drop those other providers and save myself some money. This question over here is being answered as, where should I optimize my website? What platform? I know that most of my data, or most of my users are accessing using Apple. So if I care about optimizing for accessibility, then I need to choose Apple for compatibility. But that only matters if that's an issue. If I can design my website universally and that's not a problem, that's wasted space. I just spent time looking at something that doesn't tell me anything useful related to my business. Same story. This tells us where people live when they access our website. That would be great if I sold goods and I was trying to figure out how to optimize my distribution strategies. Meaningless if I sell services that are independent of where I live. Maybe then what I really care about is what language do people speak in the countries that are accessing my data. Final point, if we look at this web traffic, we have to ask ourselves, why do I care? What is this telling me? Okay, there's a spike in March, there's a spike in August. So what? What did we do as a business during those times that drove that traffic? We don't have the right questions and the right information on this graphic for that to actually be useful. A better use of this space would have been to overlay activity with the web traffic. So now I could look at that and say, I know what we need to do more of and less of. So the point of looking at this as a starting place is that it's something we can all understand, and it highlights the importance of the question. Data science as a useful application for insight begins with asking the right questions. So let's take a look at the process. As I mentioned, it all begins with a question. We have to start with knowing what is important to our business. What do you as a business owner need to learn in order to be successful? What challenges do you have that you need to overcome? Everything begins with building a book of questions. From there, we then need to apply an understanding of our system. What do I know about what I do that informs how that space works and what I might need to measure in order to answer the question? Right? So this is where we translate question into metrics. Ultimately, we need to measure something, right? But how do we know what to measure? I think a lot of people skip these steps and they just start measuring stuff. Why are you measuring that? How is that related to what you do and what is important to you as a business? Are you coming up with questions after you've measured? That's the wrong way to go. So you need to look at your system and say, what changes? What is impacted by what I do that I can measure? The next step is to think about how you're actually going to collect that. That one's relatively straightforward, but we'll show some examples of how that might get challenging. The next part, though, processing data. What's the difference between collecting and processing? Well, a lot of times we don't actually care about the raw data. It's not as informative. Let's say that I was interested in a golden room. I have a space that performs exceptionally well. I always yield the most in that room, and I want to know what's different about that space compared to other spaces. Well, I don't actually really care what the temperature, the humidity, the vapor pressure deficit is. What I care about is how different those are in each room from that golden room. So actually, the more informative metric is the difference. So why would I show my decision makers that raw data when instead I could plot the difference? Because that's what they're really looking for. So the goal here in data science is not only to figure out how to measure things and answer questions, but what do I do with that information so that when I display it, it's as informative as possible and as simple as possible. We often miss this step and find cultivators who stare at squiggly lines and say, sure, yeah, it looks great. We could probably make that cleaner. From there, once we've simplified things, then we can look for those patterns and we can take actions. And we can cycle through this over and over again to see the impact of what we're doing. So as you can see, it's systematic, and you need to go through these steps. And in going through these steps, we answer really two basic types of questions. We're answering either an investigation or we're monitoring. If you're investigating, you're saying something happened. I did a thing, I saw a thing, I had a yield. Why? Why did that happen? You want to know that so that you can do it again. The other side of this is saying, I already know what I need to do. I just want to make sure I'm doing it. All right, that's process monitoring. So there are two different types of questions. So you need to identify what flavor question you want to answer before you begin this process. So we're going to look at those two types of questions, and we're going to tie this back to the grow. Let's look at an example of an investigation. Here's some data from a trial that I ran. And in this trial, we had two rooms at a huge greenhouse. One was a Fluence room. One was a competitor. And the competitor the client said to us, hey, your fixtures are running hot. They're heating up my room, and we're seeing heat stress compared to the competitor. It's a pretty concerning claim for a lighting provider. So if you think about this, if I need to address this, I have two pieces of information I need, two questions I need to answer. First, I need to answer the question of, is there actually a difference in temperature in this room? Is that real? Separate, but equally important, are the fixtures actually warmer than the competitors? Two pieces to answer and rebuttal one claim. So when we looked into the data, we pulled their records. They were a pretty good record keeper, so we got all their climate data. And indeed, the rooms were warmer. The Fluence room was hotter. Box on the right, taller than box on the left. Simple box plot, powerful insight. This is real. So now that I know that this is a real thing, I have to answer the question of, are our lights causing us? So how did I do that? How do you tell if the lights are warmer or not? That's a little bit tricky. Well, I took an infrared camera and we photographed every fixture in each room. And then we pulled out the average temperature for each fixture and plotted it. And when you look at that, you can see red box is competitor. Red box taller than green box, our stuff. Again, simple graphic. What does that tell us? That tells us that our fixtures actually ran cooler. So, real difference in temperature in the room, not the fixture's fault. If the fixtures had anything to do with it, the competitor's room would actually have been warmer. So, we have to finally look at something else. There's something else causing this. Turns out, when you looked into the history over time, the Fluence room consistently heated up faster than the competitor's room. So it would accumulate more degree days over time than the competitor's space. And the only real difference between those spaces was their location. The competitor's room was at the edge of the greenhouse. It was the only room that was on the edge. So it had two big walls made of glass that are poorly insulated and leak heat. Our room was sandwiched between a bunch of other rooms, and so it was well insulated. So it would warm up and accumulate heat faster, whereas the other room would bleed heat. Both of them on the same set points for their equipment. It was the room location, not the lights, that caused this difference. So what's the solution? Not changing your lighting, it's managing those spaces separately. Only with systematic and well thought out questions and application of the appropriate data science process were we able to, one, not only validate that our lights are the best in the world, but also show to the customer that they had a management challenge that they were unaware of. Why were they unaware? Because they hadn't realized that they needed to ask those questions. They had the data. They collected it for years, but they lacked the insight. Now they have it. So let's look at a different question. This is a process monitoring question. And I'm going to pose a thought here. So defoliation, we all do it. We know that you got to get light and air to the lower canopy to grow competitive, healthy, high-quality plants, right? That's why intercanopy, subcanopy lighting works so well. We know that there's value in that. We also know that labor is really expensive. So we're paying a lot of money to do something and we know it's critical. How do we know it works? How do we know that we are consistently applying this method from table to table in a harvest, from room to room in a year, from worker to worker in a shift? If it's that critical and we're investing that much into it, why don't we know objectively if we are successfully standardizing this practice? I've only met a few growers who actually do this. So let's apply the process. The question is, how do I know if defoliation is standardized and under control? What do I know about my system that changes when I defoliate? I'll give you two things. One, the amount of light that flows through to the bottom of the canopy changes. You take leaves off, more light gets down there, so it gets brighter. So we could measure PPFD at the bottom of canopy after defoliation under a standardized top light intensity. And that could be a metric. That's cool. That's great for small scale. It's cheap. It's easy. But it's not something you might want to scale up. That could take a lot of time to measure for a big grow. So this is great for an individual grower or a craft grower. For a large grow, another thing that changes is the amount of bud sites we can see. You take leaves off, you see more bud sites. So you can imagine if you had a top-down bird's eye view, you rip the leaves off, now I can count more bud sites. Not really possible for a person, super easy for a camera and a software algorithm. So expensive to deploy, but at large scales, this provides nearly real-time information on how your defoliation is unfolding. So this is a solution that might be highly valuable for an MSO or a very large single-state operator. Two metrics. Depends on the situation which one's the right way to go, but you got to pick one. So we move through our process. We've identified our metric. In this case, let's pick light because I'm a lighting guy. And let's look at a hypothetical scenario. So here we go, top graph. Let's focus on that. We send a crew in and we say, hey, crew, go defoliate, apply your practice, and then we take measurements. And so what we've got here is we've got 6 tables in this theoretical room, 3 people working, John, Naomi, and Sally, and we have each of them measure the 2 tables that they were responsible for after they're done defoliating their first pass. And what do we see as the harvest manager? Right, I'm the guy running the grow. I take a look at my data and I say, hey, John and Naomi nailed it, right? They're right in that line. Well, let's assume that we did a trial before and we figured out that 150, 200 PBFD is ideal. So that's great. But if we look at Sally's tables, Sally has under defoliated. It's too dark under there. We need more light. So we need to send Sally back in to take some more leaves off. So now we have avoided a situation where we have an asymmetric application of practice to a room, and we can standardize that. But we could do more with that data. We can now look at the history of each worker and say, is this an isolated incident, or do I need to intervene on what Sally is doing? And when we look at history, we can first off identify that Naomi is a rock star. She gets it right every time. John, he's had an off day, but is generally pretty good. And Sally consistently under-defoliates. So as a manager, what I can do with this is, first off, I can identify and reward that talent, and I can promote promote Naomi to a lead position, and I can justify to my executive team why it is that I need to allocate those FTE funds. Second, I can tell Naomi, I need you to train Sally. We need to intervene to prevent this problem. This is something that happens a lot with data, is that you may approach one question, it collects something. Approach another question, collect something. But as you collect more and more data, you start to get emergent value, and you have the ability to answer more complex questions. But the key here is that each of the questions that I ask is there for a purpose. So you can imagine this on a dashboard as something that somebody looks at routinely and is able to make very quick, very powerful decisions. Guys, these are just box plots. You make this in Excel. This is very straightforward. This is not complex. It's just powerful. So there is a difference between measuring and insight. And data science isn't about being complicated. Data science is about being intentional. So with these two examples, I want to take a moment to just kind of conclude something. First is that data is a process, right? Data science has a defined process, just like the scientific method. If you don't follow that process systematically, you will most likely make errors and become frustrated and leave money on the table. But if you do, you will probably arrive somewhere that creates value for you and your company. Second is that data is not about big tools. Data is about asking questions, identifying metrics, collecting data, and processing it intelligently. It's the clarity of the method that matters, not the complexity of the tool. You don't need to be an expert to take these first steps. You can do this whether you're a home grower or you're the director of a large-scale operation. It doesn't matter. You can start simple. You can always build. Finally, you do have to recognize, though, that it may become necessary at some point to invest in expertise. Just like being a cultivation manager or a process extractor requires certain skills, as your questions become more complex, your ability to answer them yourself may diminish. You may just simply run out of bandwidth. So there is a point where investing in a data scientist or even a data science team may create more value to you and eliminate a plateau. But that doesn't prevent you from starting at square one. So finally, I just really want to reemphasize the point that data science at its core is meant to be accessible and empowering. Start simple, ask intentional questions, and take steps to measure and refine what matters the most, and you'll be successful. You can always build from there, but if you don't start at that point, you almost certainly will become lost. Thanks.